Hey guys, Miss Fearing here. Today we're going to look at Unit 3, Notes 1, which has the learning target, I can identify the parts of a polynomial. There's going to be quite a few definitions in this video. It's extremely important that you know these definitions so that when we use the terms, you understand exactly what it is that we're talking about. So really make sure that you have a good understanding of the terms coming up in the video. So the first word we're going to talk about is base. The base is the number in the power that is being multiplied. So if I'm looking at this example, 2 to the third, that 2 is my base. So the exponent then is the number in a power that tells you how many times to multiply the base. So the 3 is going to be my exponent, and what it's telling me is I'm going to do 2 times 2 times 2 3 different times. So this is going to equal 2 times 2 times 2. Our next word is term. A term is a number, variable, or the product of a number and or variable. Terms are separated by addition and subtraction. So a term can be 2. 2 is a term. 2x is a term. Y is a term. All of these things are different terms, and usually you'll see it split up by like 2 plus 2x minus 3y squared. These all are separate pieces, so those would be our number of terms. Next, we're going to look at coefficient. The coefficient is the number part of a variable term. So if I give you 7a, 7 is the coefficient. That's what I'm talking about when I'm talking about the coefficient. It's the number part of that term. The degree of a term is the exponent on the variable of the term. So if I were to give you 5b to the 4th power, this power or that exponent tells me the degree. That would tell me it's a degree of 4. When you're looking at this, you always want to look for the highest exponent in your polynomial to find the degree. Constant. You've heard this word before. Constant is the term with no variable, so it's just the number. So any number that you could possibly have, those are all constants as long as they don't have the variable with them. Like terms is also something we've talked about before. Like terms are terms that have the same variable raised to the same powers. So if I had 2x squared and 5x squared, those are like terms, so that if I put them together, if I added them, I could get 7x squared. So be careful with like terms. You don't touch the powers at all. The powers stay the same. It is just adding those coefficients. So now we're actually going to talk about a polynomial and a couple different definitions of polynomials. So when I'm talking about a polynomial, I'm talking about a set of terms separated by pluses and minuses. So just like before, if I had 2x squared plus 4y minus 2xy, this is a polynomial because it is 1, 2, 3 different terms separated by addition and subtraction. If I'm asking for the degree of a polynomial, I'm looking for the largest exponent of all the terms in the polynomial. So I kind of touched on this a little bit earlier, but if I had 2x to the 4th plus 7x to the 7th minus 2x, the highest or the largest exponent is the 7, so this would have a degree of 7. In order to go ahead and find those degrees, usually I ask that you put them in standard polynomial form, which is when all the terms are combined, all like terms are combined, and terms are written in decreasing order according to the exponent. So we write the largest exponent first, and then we decrease from there. So if I was going to rewrite this polynomial in standard form, I would do the largest exponent first. So that's the x squared. So I'd have 7x to the 7th. and then I would decrease from there. So the 4 would be next, and then the x. Remember, this has a power of 1. If there's nothing there, it's an imaginary power of 1. So here's our last definition before we go ahead and get into examples here. So the leading coefficient. The leading coefficient is exactly what it sounds like. It's the coefficient of the first term. The only trick to this is, right here, it's extremely important, the polynomial has to be in standard form first. So if I had something that was in decreasing powers, or exponents were decreasing order, then the leading coefficient here would be 2. That would be my leading coefficient. So let's look at this first example here. Number 1 asked me to write it in standard form first. So standard form, remember, is largest exponent first, decreasing order, and all like terms combined. So I'm going to look here, and the largest exponent I see are my x to the thirds. So I'm going to go ahead and I'm going to put those together, combine those first. So I have a 4x to the third and a 3x to the third. I have 7x to the third. Next, I'm going to look for my x squared. So I have an 8x squared and a negative 5x squared. So I'm going to end up with a positive 3x squared. Go ahead and look at your x's now. I have a negative 3x and a positive 5x. So I end up with a 2x. And then going on to my constants, I have a positive 8 and a negative 12. So I'm going to end up with a negative 4. So I am starting with my highest exponent and it running in decreasing order. All of my like terms are combined. So this is my standard form. So now if I'm going to talk about how many terms there are, remember a term is just split apart between the pluses and the minuses. So I end up with a 1, 2, 3, 4 terms. So number 3, what is the degree of the fourth term? Well, the fourth term was this negative 4. And remember, anything that does not have an exponent has an imaginary 1 there. So the degree of the fourth term is an imaginary 1. I want to go ahead then and I want to list all of the coefficients. So all of the coefficients are the numbers in front of the variables. So I have a 7, a 3, and a 2. The negative 4 does not have a variable, so that is not a coefficient. That is actually my constant. That's the number alone. So this negative 4 would be my constant. So example number 2, we want to write this in standard form first before we answer any of the other questions. So remember, standard form tells me I do the highest exponent first, like terms combined. So the highest exponent I have is 3x to the third, and then I also have a 2x to the third. So I'm going to go ahead and add those together, and I get 5x to the third. And I'm going to do with my x squareds. I have a 2x squared and a 5x squared, so I get plus 7x squared. Now my x's, I have a negative 3x. That's the only one I have, so I have to make sure I keep that. And then last but not least are my coefficients. I have a negative 12 and a negative 6, so I get a negative 18. So now we can answer all the other questions. How many terms are there? Well, again, a term is split up between addition and subtraction. So there is 1, 2, 3, 4 terms. The degree of the fourth term, well, 1, 2, 3, 4 is my 18 is my fourth term. Remember, the degree, if it's nothing there, is an imaginary 1, so I have a degree of 1. List your coefficients. Coefficients are the numbers in front of the variables. So I have a 5, 7, and negative 3. But that negative 18 doesn't have a variable, so that is how I know that's my constant. So example number 3, we want to write it in standard form before we find the degree or the leading coefficient. So standard form start with the highest exponent, which in here is the 5, And I only have the 1, so I'm just going to have 5x to the 5th. So now I'm going to look and see, do I have any x to the 4ths? I do not. So now I'm moving to x to the 3rds. I have a 3x to the 3rd and a negative 2x to the 3rd. So I get a positive 1x to the 3rd. I don't have any x squareds, so now I'm going to look at my x's. A negative 2 and a negative 4 gives me a negative 6x. And now I'm going to deal with those constants. So I have a positive 4 and a positive 5 gives me a positive 9. So since I'm in standard form, I can go ahead and answer the next two questions. The degree of the polynomial. Degree is the exponent of the first term when you're in standard form. So I'm in standard form. My exponent of the first term here is this 5. So this is going to be a 5th degree polynomial. The leading coefficient then comes from the coefficient in the front. Remember, the coefficient is the number in front of the variable, so it is going to be a 5. Notice that I did not write the rest of the coefficients down because I want the leading one, only the leading one. So last example here, I want you to go ahead and pause the video, try these on your own, find the standard form, the degree, and the leading coefficient, and then unpause the video and check your answers. So here are the answers that I ended up getting. If you had anything different and you don't understand where these answers came from, please go ahead and stop the notes, come over and chat with me before starting your next assignment.